Imagine you're overseeing a big project, maybe a bridge, a skyscraper, something meant to last. You're planning every detail, making sure the materials are top notch. You want the best concrete, right? But what happens when, a key ingredient, something you rely on for performance, suddenly gets hard to find? It's like needing that one special part for a complex machine and poof, it's just not available. Today, we're doing a deep dive into exactly that kind of challenge. We're looking at concrete admixtures, specifically something called silica fume, and importantly, what smart alternatives are out there when the supply chain gets, well, complicated. We're digging into insights from Master Builder's Solutions Guide, AI3 Alternative Products, SF.pdf. It's pretty revealing about market stuff and some clever fixes. So our mission today, uncover what this ingredient is, why getting it can sometimes be a puzzle, and explore those performance-driven alternatives for when things get tight. Get ready for some, maybe, aha, moments about how global economics trickle right down to the foundations of buildings.
Yeah, what's really fascinating is how these very technical details, a specific additive, are so deeply connected to bigger market structures. It's not just about what you put in the mix. It's also about, availability, strategic planning, and how you make sure you still get the performance you need, even with these external challenges. We'll definitely explore that.
Okay, let's unpack this. First things first, what is silica fume? And why has the Masterlife SF100 version been such a big deal in concrete? Because silica fume, it doesn't exactly scream essential component to most people, but this source definitely treats it that way.
Right. The name is pretty unassuming for what it does. Silica fume is uh, a very versatile ingredient. You add it to concrete to seriously boost performance in lots of different ways. It's actually a powder, superfine amorphous. It's a byproduct, interestingly, from making silicon and ferrosilicon metals.
A byproduct.
Exactly. Its value comes from its unique properties.
Yeah.
It's a highly reactive pozzolan, and it also acts as a microfiller. So what that means is it significantly improves the concrete matrix, makes it denser, stronger, much more durable. Think of it as like a supercharger for concrete performance.
Okay. Denser, stronger, more durable. Sounds great. Which brings us to the core issue here. If it's that good, why would getting it ever be a problem? Seems like something everyone would want readily available. But our source points to a very specific reason for shortages, and it's bigger than just a temporary hiccup.
Yeah, and this gets into market structure, global economics, things that you, the listener, really need to factor in. The global market for silicon metal, which is where silica fume comes from, operates as an oligopoly.
Oligopoly. Okay, what does that mean in practical terms?
It means just a few large companies dominate production. So the supply and demand for silicon metal itself, which goes into electronics, solar panels, lots of things beyond concrete, it fluctuates. When those bigger markets shift, silicon metal production changes. And because silica fume is a byproduct,
Its supply gets squeezed too.
exactly, the supply can become constrained. And what happens then? Allocations. Suppliers might only get a fraction of what they ordered, or they face really long lead times.
Right. And you can imagine on a big project, a highway, a dam, you can't just hit pause for months waiting for one ingredient.
Absolutely not. The delays, the costs,
Yeah.
it would be huge. Millions, potentially. Major setbacks.
So the ingredient you designed your mix around is suddenly hard to get. Stopping isn't an option. That's where the alternatives come in. Master Builder Solutions offers a whole suite of them. But as you hinted, it's not like just swapping sugar for Splenda, right? It's more complex than that. What are some traps people fall into when they try to substitute something like silica fume?
That's a great point. It's not a generic swap. You have to know why you were using silica fume in the first place. What performance were you targeting? Was it mainly for corrosion protection or maybe ultra-high strength? Better workability. A common mistake is thinking all pozzolans, these reactive materials, are the same. They aren't. Different chemistry, different particle size, different reactivity.
So you're replacing the function, not just the material name.
Precisely. And crucially, you need to figure out the right dosage for the alternative. That often means doing trial mixes, testing. You have to prove you're still getting the performance you need and meeting all the project specs. It's very performance-driven.
Okay, that makes total sense. Let's get specific then. This is where the rubber meets the road for people actually working with concrete. Let's say a project really needs concrete that can fight off corrosion, especially from chlorides. Think coastal areas, bridge decks with de-icing salts. What alternatives does the source suggest when silica fume isn't available?
Right. For that tough chloride-induced corrosion protection, the source highlights a few solid options. You've got Masterlife CI30, Masterlife CI222, and also Masterlife MK828 admixtures. Each one works a bit differently. either by directly inhibiting the corrosion process on the steel inside the concrete or by making it much harder for those chlorides to even get into the concrete in the first place. Absolutely vital for long-term durability in those aggressive environments.
Okay, protection covered. What about just making the concrete stronger? Both compressive strength resisting crushing and flexural strength resisting bending. Both are fundamental, especially for high load structures. What's the alternative for strength boosting?
For strength, the go-to alternative mentioned is Masterlife MK828 metakaolin. Metakaolin, like silica fume, is a powerful pozzolan. It reacts chemically inside the concrete. It basically consumes a byproduct of cement hydration, calcium hydroxide, which doesn't add much strength, and turns it into more strength-giving compounds.
Ah, so it makes the internal structure better.
Exactly. It densifies the concrete matrix, makes it stronger, less permeable. Very effective for both compressive and flexural strength. Now, you typically use it with a high-range water reducer, like the Master Glinium or Master Rio Build series. This lets you use less water, which also boosts strength, while keeping it workable. But an important note, it's not always a direct pound-for-pound swap with silica fume. You might need to adjust the mix design, the dosage, to hit the same strength targets. Trial batches are key.
Got it. So testing is crucial. Now, concrete faces other environmental battles too. What about sulfate attack? That's a big one in certain soils. Or around, say, industrial wastewater, sewer pipes. How do these alternatives help there?
Yeah, sulfates can be nasty. They react with the cement paste, cause expansion, cracking, basically disintegration over time. And again, Masterlife MK828 metakaolin is highlighted for providing resistance here. It helps by changing the concrete's pore structure and consuming some of the compounds that sulfates like to attack. So it effectively neutralizes those damaging reactions, protecting the concrete in those specific, tough chemical environments.
Okay, so MK828 is quite versatile. We've talked about protection and strength, but concrete also needs to be, well, usable. It needs to be workable when you pour it, easy to finish smoothly. What about alternatives for controlling things like viscosity and stability, making sure the mix behaves properly?
Right, controlling the recology, how it flows, is critical. For that, the source points to the Master Matrix series of viscosity-modifying admixtures, or VMAs. These are designed specifically to tweak the concrete's viscosity. They make it more stable, more cohesive. What that means practically is they help control bleeding water rising to the surface and reduce segregation where the heavy bits settle out.
Which makes it easier to place and finish properly.
Exactly. Much easier placement, consolidation, even extruding if you're doing that, and getting a good finish. Really helpful for tricky mixes, maybe very fluid ones that could otherwise be hard to manage.
All right, and one last specific issue. Alkali silica reactivity, ASR. This happens with certain aggregates, causing cracking over time. A known headache. What does the source suggest for tackling ASR when silica fume is off the table?
For ASR mitigation, the source lists two main alternatives. First is Masterlife ASR 30, and second, popping up again, is Masterlife MK828 metakaolin. Both are engineered to interfere with that damaging reaction between the alkalis in the cement and reactive silica in the aggregates. They stop the formation of those expansive gels that cause the internal stress and cracking. So it's about protecting the concrete from this specific internal threat long term.
It's really clear these aren't just simple drop-in replacements. You can't just say, okay, no SF100, I'll grab some MK828.
Okay.
There's a crucial final step, isn't there, to make sure everything lines up with the project needs.
Absolutely critical, yes.
Yeah.
While these alternatives from master builder solutions are effective, their use must be approved by the project specifier. That's the engineer or architect who wrote the specs, defined the required performance.
So how does that approval happen smoothly?
Well, the source explicitly says, Master Builder Solutions has engineering and marketing teams ready to help. They can assist with tweaking the mix design, provide the technical data, guide the selection, basically help ensure the chosen alternative is implemented correctly to meet those specific project demands without any compromise. It's framed as a partnership.
Okay, so let's bring this all together. What's the bottom line here for you, the listener? Maybe you're planning, maybe you're building. We've taken this deep dive into concrete admixtures. We've seen how something like a global oligopoly in silicon metal can ripple down and affect silica fume availability. But I think more importantly, we've seen that there are smart, tailored alternatives ready to step in. Solutions that ensure projects can still meet the highest performance standards, even with supply chain curveballs. It really shows the adaptability in material science.
It really does.
Yeah.
And it highlights how important it is to not just know what materials to use, but to understand the why. Why are there supply issues? What are the underlying dynamics? And what's the full range of solutions available? It definitely pushes for a more proactive, informed way of selecting materials and solving problems in construction. It kind of reminds us that knowledge is most powerful when you understand it deeply and apply it strategically to these real situations. And maybe here's something to think about. This oligopoly effect we talked about for silicon metal. How might that same dynamic, a few big players controlling a key raw material, be quietly shaping other industries? Or even products you use every day? Think about other unseen supply chains. What might be dictating availability, cost, maybe even innovation in areas totally unrelated to concrete, your phone, certain foods? It's a pattern worth considering.
That's a fascinating thought to leave folks with. Thank you for joining us on this deep dive. Until next time, keep digging, keep learning, and keep building smart.